everyone, and welcome to the Engineering IRL podcast for engineeringinreallife.com. Today is revision 35 of the show. Yes, we're 35 episodes in. Nice. And today I'll be walking you through a cybersecurity vulnerability assessment, CVA for short. Kind of what's the steps involved, why it's important, like where it adds value, and I think we can probably get some sort of lesson. Something we can apply to real life from it too. All right, so to start, cybersecurity vulnerability assessment, sort of in the name, but it can get confused with what's known as a penetration test. So the penetration test is something where you actually go in and try to break into a system, whereas a vulnerability assessment figures out where would a penetration tester attack, or where would an attacker attack for that matter. And it's kind of interesting and eye-opening when you take this kind of lens and look at your systems, because essentially what you spend most of your time in is figuring out how to make a system run, how to make it as convenient as possible so I can keep it running. But then you have to go at a second lens afterwards and be like, all right, now I can make it run. How do I make it run for the people that it should run for? How do I make sure it only does the things that I want it to do? And that's where a vulnerability assessment can help you, because there is a step-by-step kind of look at how things go, and I'll break it down into three major steps. Okay, the first step is like the physical look at things. What kind of documentation you have in place, what kind of awareness and programs are there, procedures, policies, all that sort of stuff. It's like a visual look, right? You look at the security, you look at the physical security, you go and check, can anyone walk in and access this sort of equipment? How easily accessible things are? Can you make changes without being seen in certain locations? Are there adequate locks and storages and all that sort of stuff? You don't just look at the live equipment, you might look at the backups. Where are they kept? Oh, the USB on someone's desk. Or you might, have an inspection of the work areas and you find passwords on post-it notes, things like that. Any kind of observations. You're basically going in and just absorbing everything, getting a feel for how people approach cybersecurity at the moment, and then understanding what they have in place, and then physically looking at the equipment and just seeing if anything stands out. I find that many times you can see that there's a secret switch, some other connection port that has 40 free ports that no one knew about that is another way into the system, things like that. That's the first step. Second step, what you do is you actually do a more active scan of the network. So you connect into the networks, and it's essentially doing some recon work. You're going in and you're interrogating the system to find out what it can tell you about itself. Okay, everything, maybe everything that's accessible, right? So it'll tell you versions about what software it's running, operating systems. Maybe you can find out what ports are listening, are open on different services. The services themselves, what are people running, and then those versions as well. And most of these scanner type programs are pretty sophisticated in that they can tell from the way that a service responds that it's probably this version of that software. You're looking for anything on the network, and you want to know what's on there. Is the list of things that respond look like what they should look like? Are they what you expect? So no rogue devices. And essentially you go to every single network and you do this. You have to be careful, of course, and you might set off a bunch of alarms in different places, because the scan can be quite aggressive and it takes time. The more detailed the scan you want it to be, then the longer it will take. And there's other tools that test for specific vulnerabilities. So there's many databases of vulnerabilities out there, and they might scan, does your system have that? Not just, do you have this version? It also checks. It's like it tests the exploit a little bit. It's like, there should be a gap in your wall here. It feels, there is a gap. You have this gap. So that's the second step. That's more the aggressive kind of look into the system step. And you'll do that for every single network. You typically won't try to broadcast this over a big range. You would go to each subnet and basically connect in with permission. So that's why I'm saying it's not really like a penetration hack. You're not trying to figure out how you can get in without anyone knowing. You have some level of access to the system to interrogate it. Okay. And then the third step is essentially taking all of this back in, and you do the digesting and the correlation. You have a look at all the systems, all the devices, all the softwares, and what you do is you find out what they have, what vulnerabilities they have, and then you might take a peek in and see what kind of, if there are exploits available, and more importantly, if there are patches available. Okay, so that's actually what you want to do. And it's easy enough to say, oh, just update all your systems to the latest. And yeah, that's always the case, and that is a good thing to do. But sometimes you want to know specifically what vulnerabilities you have, because you may not have the opportunity to update, and so you need to know what you need to mitigate. So these are kind of the 3 steps during it, right? Like the way you might structure it as a project will be different. You have different steps where you do interviews, and you kind of scope out what the client wants, what they want to find out about their systems and how far and wide that search goes. But one thing to note is the reason why patching is such a huge deal, right? It sounds lame. It's like, oh, the answer is patch your systems. Cool, thanks. But it is actually surprisingly important, because what happens is every time there's a vulnerability found, so think of it as a bug in the code. There's a spot in this software where it behaves unexpectedly. Okay, that's all a bug is. That's your vulnerability. Okay, but it may not mean that it's that exploitable, or that you're not imminently going to be hacked because you have a vulnerability. Every system has vulnerabilities, and almost every code has bugs. So you get a vulnerability when someone finds a bug and then they report the vulnerability. Now we know there's a vulnerability in the software. So that's one point in time, okay? The announcement of the vulnerability. Then during that time, hackers will start developing exploits for that vulnerability. And at the same time, the vendors, the manufacturers, usually Microsoft or Apple or whoever, are developing a patch for the vulnerability. And what they've done is they've taken statistics of the major node ones. This was a review done by Tenable, and you can see that the attackers have an advantage. On average, the exploit comes out before the patch. Okay, so an exploit's developed, and then there's a patch. Okay, so then when that becomes you think that's a really vulnerable window, because there's no patch. Even if you wanted to protect against the vulnerability, you can't. There's no patch. And then there's another date, which is looking at when an exploit was successful, when there was a successful attack. And this is where things get interesting, right? So just imagine the following. There's a successful hack. Then you want to know what vulnerability was there. Was there a vulnerability? Yes, there was a vulnerability that was reported and known. Cool. Then you find out there was, maybe let's call it a week later, an exploit was developed. And 2 weeks later, the patch was developed. And you might think, okay, so that means most likely you got hacked somewhere between there, before the patch happened, so you couldn't do anything about it. But it turns out, on average, when a successful attack happens, it's 6 months after the patch has already been released. So forget this little window of you couldn't have done anything about it. 6 months after there's a known patch published to the world is the average time an actual successful attack happens. You haven't updated that, for more than 6 months, and that's interesting. It's interesting because you say at first, you have your conclusions, but then you go, you know what? A patch isn't a big deal to do, right? It's a little effort to put in a patch, but the result is, 80% of the hacks, successful ones, happen because of out-of-date patches. So then for this little effort that you have to put in, which is like 20% of your overall cybersecurity efforts, is patching. It's very simple, it's not complex, it's there's some complexity, but the answer is very easy. Patch your systems. The complexity comes with how and how often, and without breaking the rest of your system. But your overall cybersecurity effort, 20% patching, you get 80% increase, of your results, right? And so this is why the answer is always patching, because the stats, numbers don't lie, right? And so the whole point here is that is something worthwhile doing because it has such a big impact. Okay. Then the rest of the assessment will tell you all sorts of stuff. Usually recommendations will happen about what you should and shouldn't be doing, maybe some best practices. And what you do is, in the digesting phase, you're comparing it to certain standards, because you can't really measure the security wall, right? You're building a wall for your security. You can't measure how tall it is, really. But one way you might do it is to compare it to a standard, because I think that's fair. That's something measurable. You can say, how close is the security to the standard? And then here's all your vulnerabilities, here are the suggested fixes. And then in lieu of that, or in addition to that, there's additional layers of security you could do that are in these best practices that could be suitable for your scenario. That's what we do in the vulnerability assessment overall. So that's a CVA. And it's a pretty in-depth look, and it takes time. It's not a secret how it's done. There's standards on how to perform on. NERC SIP has the whole thing, and it has a workflow and everything, so you can just follow that. But the reason why it garners so much attention is two things. One, and money for you engineers, is one, it takes time, it does a lot of work, and you need specific knowledge. And two, you kind of want to make the right recommendations about it. And I'm going to add a third one. Three, it's like you don't want to damage the systems that you work on. So you need kind of this combination: analytical mind, inquisitive. You got to ask the right questions. You got to be looking. You can't be shy. You can't just tick some boxes. You got to actually look and ask people questions. You got to ask randoms like, "Hey, what's your cybersecurity policy on this?" Or, "Hey, if I give you this USB, what do you do with it?" Like, you may ask these questions. And you can kind of teeter a little bit into the penetration testing world, but not deeply. But you can have a quick go at a client and see how far in you can get to it, right? So it is a pretty full-on job, and then the analysis takes ages because there's a lot of systems and components you're looking at. Then you're looking at their vulnerabilities. Then you're looking at the possible exploits. Then you're looking at the possible solutions, and you're kind of tying it into this big thing, trying to digest it down, because one of the target audiences is, one, there's technical people and they love the full report details, cool. Then you got like the more C-level people, the high-level people that need to get some message from it to that they can digest. It's not full just technical blabber. Cool. So that's what's in a CVA. It's a lot of fun. I've personally gone out and done some, and especially in the critical infrastructure world, it's very interesting because this is what runs your society: electricity, transport, waterways, all that sort of stuff. Now we're looking at cybersecurity, and it becomes really important. It's always been important, but I think it's becoming more accepted to look at it with a more detailed lens. And there's a maturity now achieved where we can do it in a way that doesn't really interrupt processes. Like an IT person doing a vulnerability assessment in industry is a no-no. Okay, don't do that. They trip plans, they cause blackouts. Like, it's a different beast, is what I'm trying to say. All right, cool. So what's the lesson? Right? Where can we apply it in real life? Really, it's a support of the 80-20 rule, to be honest. Like, there are things that you must do, which seem like basics, but then the actual numbers come out, the stats come out, and you go, it has a profound effect. Same way that patching to maintain a system, it's like, yeah, I get it, patch my system, it's annoying, but the value that you get and the numbers that show how successful attacks happen 6 months after, you go, it's reasonable. Up to date within 6 months. Most of your IT policies are like, one day, right? And it's only asking for 6 months. But then the upside is so large. So what can you find in your own life? Problems or situations or things you're supposed to main that require just 20% effort. You know what it is. You know the answer to half the stuff, but you don't do it. And you don't really see this immediate effect. You're like, I don't really get hacked every other day, right? Or this problem doesn't emerge, like your health or your fitness or whatever it is. So you don't do it, right? But there's tremendous upside. And so that's kind of the point here. It's like, well, you can prevent most things and maintain things and keep it going with a pretty loose regiment, right? but as long as you do it and keep it up. The low-bearing fruit, address that first. We all try to go for the big whale, the big, like, this will fix all my problems. Let's start with the basics first. The one thing that you know you should do for the maintenance of something. Your health, your finances, whatever. Relationships, whatever. And do that first before looking for these big whale things to fix things. Because same in the cybersecurity world, before we even move forward to all these more advanced techniques, which we do suggest, and I do provide more advanced, answers and critical analysis, which gets you that, the rest of the 20% of the security. Before you do any of that, you need to address first your vulnerabilities. That being said, I'm really happy with the episode today. I think it'll be an interesting one, and I thought I'd just touch something on the cyber side and give you a bit more walkthrough. And then, of course, thanks again for tuning in. Obviously, this is another podcast that we've done, another episode that we've done where it's been recorded and posted online and all that sort of stuff, just to give some variety to it. And then after this episode is obviously clearly recorded with some headphones. I'll be doing a bit of an unboxing, and I bought some equipment and we'll be testing them out. I've got 2 separate microphones. One's with Audio-Technica. The other one is the Razer Siren Elite, which I'm excited to use, which I'm picking up right now actually. So I'll get that, and then the next couple episodes will be recorded with that, and then we'll see how much the audio quality improves. And the other part of the step is obviously I need to increase my volume. So we'll do that. And thanks again for tuning in. So we'll see you in the next one.
This is the Engineering IRL Podcast, a place for engineers in the real world. We try to break down engineering concepts and figure out how to apply them to real life. Let's become better problem solvers, better engineers. This is your host, Andrew Sario. Let's begin.